Good day grade 6 learners. Welcome to our lesson in Mathematics 6. Term 1, Week 1, Session or Day 4. Our topic for today is tessellation with translated, reflected, and rotated figures, shapes. Please don't forget to like, share and subscribe. Thank you. Here are the basis of our lesson for today. A. Content standards. The learners should have knowledge and understanding of the tessellation of shapes, translation, reflection, and rotation with shapes. B. Performance standards. By the end of the quarter, the learners are able to tessellate a surface using different shapes. C. Learning competencies and objectives 1. Explore whether or not a shape tessellates. Tessellations. Define tessellation and explore whether or not a shape tessellates. Illustrate translation, reflection, and rotation with shapes. Tessellate with translated, reflected, and rotated figures, shapes 2. Draw resulting images of shapes that undergo translation, reflection, and rotation. Translation, reflection, and rotation with shapes 3. Tessellate a surface using different shapes, including triangles, squares, and rectangles. Developing and deepening understanding. Explicitation. Tessellation is a captivating art form where geometric shapes fit together seamlessly, covering a surface with no gaps or overlaps. Tessellations can feature translation, reflection, and rotation of shapes, figures. Combining these allows artists to create intricate and mesmerizing tessellations. Whether using simple polygons or more complex shapes, tessellations offer endless possibilities for creativity and exploration in both art and mathematics. Worked example. Example 1. Describe how the figures are arranged in different ways in the tessellation at the right. Solution. The answers of students may vary. Examples of arrangements. A. The pattern arrangement shows translation. Triangles slide to the right or slide to the right downward. Alright class, let's take everything we've learned and look at this beautiful pattern. This is what we call a tessellation, a repeating pattern of shapes that fits together perfectly with no gaps and no overlaps. Think of this like the floor tiles in the school hallway or a honeycomb in a beehive. 1. The power of the slide translation. In this specific pattern, we are focusing on translation. Look at the blue triangles. To create this entire wallpaper, we don't need to flip or spin the triangles at all. We just need to keep sliding the same triangle over and over. The horizontal slide. Look at the red arrow pointing to the right. We take one blue triangle, slide it to the right, and, pop, it fits perfectly into the next spot. The diagonal slide. Look at the red arrow pointing down and to the right. We can also slide the triangle diagonally to start the next row. 2. Why it works. Congruence. As our friend the detective mentions in the thought bubble, this works because of perfect congruence. Every single blue triangle is the exact same size. Every single blue triangle is facing the exact same way, pointy side up. 3. The vector. The red arrows. In math, those red arrows are called vectors. They act like a map for the shape. They tell the triangle how far to move, which direction to go. What do you see in the picture? The image shows a pattern made of triangles arranged in rows. Some triangles are pointing up, and some are pointing down. The colors, blue and light orange, help us notice the pattern more clearly. Anti-clockwise arrows. What is happening in the pattern? The key idea here is rotation. Rotation means turning a shape around a point. In this pattern, each triangle is rotated half a turn clockwise. A half turn means turning 180 degrees, like turning something upside down. Brain, let's understand it step by step. Look at one triangle, for example, a blue triangle pointing up arrow. If you rotate it half a turn, 180 degrees, it will now point down arrow. That's why the next triangle looks like an upside down version of the first one. Repeat button. What do the arrows mean? The red curved arrows in the picture show the direction of rotation. They show that the triangle is being turned clockwise, to the right. After the turn, the triangle changes its orientation. Pushpin. Important idea to remember. A half turn, 180 degrees rotation, makes a shape look flipped upside down, but it is still the same shape. The pattern repeats because each triangle follows the same rule. Right finger rotate, right pointing arrow flip, right pointing arrow repeat. Bullseye. Quick check for you. If a triangle is pointing up and you rotate it half a turn, what will it look like? Right finger answer. It will point down. Alright class, let's study this diagram. What is shown in the picture? The image shows a pattern made of triangles arranged neatly in rows. Some triangles are blue, some are light orange, all are connected in a repeating design. Across the pattern, there are red dashed diagonal lines. What is the main idea? This pattern is about repeating transformations, especially rotation and movement in a pattern. But instead of looking at one shape only, we now look at how the whole design repeats in a direction. What do the red dashed lines mean? The red dashed diagonal lines show a repeating direction in the pattern. They help us see that the triangles are not random. They follow a regular slanted, diagonal pattern. Each group of triangles is placed in a consistent direction. Think of it like the pattern moves diagonally across the page in the same way again and again. What do the triangles show? Look closely at the triangles. Blue triangles point in one direction. Orange triangles point in the opposite direction. This creates a balanced and repeating design. This tells us the pattern is built using a rule, not randomly drawn. What is the math idea here? This helps us understand patterns can repeat in different directions. Shapes can be rotated or flipped to create designs. Geometry patterns follow rules, not guesswork. This picture shows how triangles can be reflected, or mirrored, across a line, just like how your face is reflected in a mirror. The blue triangles are the original shapes. The beige triangles are their reflected copies. The red dashed lines are called reflection axes. These act like mirrors. When we reflect a triangle across one of these red lines, every point of the triangle moves to the opposite side at the same distance from the line. That's why the beige triangle looks exactly like the blue one, but flipped. Think of it this way: if you stand in front of a mirror and raise your right hand, your reflection raises its left hand. That's what happens to the triangles, they flip across the line. Key idea: reflection doesn't change the size or shape of the triangle, only its position. It's still the same triangle, just facing the other way. The green hexagons have 6 equal sides. The white squares have 4 equal sides. When we arrange them together, they form a tessellation, a pattern that covers the surface completely, with no spaces or overlaps. Each hexagon is surrounded by 4 squares, and each square touches 2 hexagons. It's like fitting puzzle pieces perfectly. Every shape connects smoothly to the next one. Answer: the pattern shows the translation. The hexagons slide or move in another direction. Example 3. Looking at the tessellation, what pattern arrangement is emphasized? The light green hexagons are the original shapes. The light blue triangles are reflected shapes. They flip across the red dashed lines, which act as mirrors. The blue arrows show how each triangle moves to its mirror image. The labels help students identify which shapes are originals and which are reflections. It's like looking at yourself in a mirror. The image looks the same but faces the opposite direction. Answer: the pattern shows reflection. Evaluating learning. Lesson activity. Students will look at the image and answer these questions. Number 1. What is the name of the red dashed lines labeled? Number 2. How do shape A and shape B relate to each other in the pattern? Number 3. Which shape is repeated throughout the tessellation? A. Square. B. Hexagon. C. Circle. Number 4. Draw the reflection of the triangle across the line below. Answer key. Great job today, everyone. You listen well, share your thoughts and work hard. Keep up the good work. Always remember to smile. See you next time.